DLSS 5's neural rendering is a problem, and what especially makes this a concerning problem is with the current direction of big tech companies repeatedly doubling down on AI innovation. Once upon a time, big corporations received a lot of money from very rich people with the expectation that these investments would eventually pay off. And we've now reached a point where we're starting to see a demand for the return in the investments. Meanwhile, the quality of our products is more of an afterthought. You see, recently NVIDIA announced DLSS 5, and look, everyone has been clowning on their demos. It's very clear that the current sentiment is less than positive. But here's the irony in all of this. While I definitely think that the showcase has been a disaster, I very much dislike the way the shots look with DLSS 5 enabled, but what concerns me the most isn't actually DLSS 5 in its current state, but instead what DLSS 5 will look in the future once it supposedly gets better. Because here's the sad reality, DLSS 5's neural rendering is most likely not going to go away. RDNA 5, which is the architecture that Xbox Helix is based on, was also advertised as having their own competing neural rendering technology, meaning that even the mainstream consoles are expected to have the same technology that NVIDIA is promoting. Now, are they gonna double down the same way Jensen currently is, especially after the backlash? It's hard to say, but the intention is definitely there. And I've already been seeing people making the exact same predictable arguments, such as how this is still the first generation of neural rendering and how, much like DLSS when it initially came out, it's eventually going to get better and more streamlined, as well as the fact that developers and players have the liberty of disabling these features as they so choose to. But the people making these arguments fundamentally do not understand the much bigger and horrifying ramifications of this becoming standardized. Because once upon a time, we used to say the exact same thing about TAA, upscalers, and ray tracing. And look where we are right now. You see, there was a time when TAA also used to be optional. You didn't have to enable it if you didn't want to. There were other alternatives for you to choose from. But look where we're currently at right now. Many games today don't even give you the option to either disable or choose a different anti-aliasing solution, and even when they do that, the end result can at times be dreadful. There's this YouTube channel called Lodo that uploaded a really good video showing what happens when you disable TAA in Tekken 8, a game that by default doesn't let you disable TAA and requires you to use a third-party tool in order to force you to disable it. But in doing so, the graphics look dithered. This is because the game was built from the get-go to use TAA, a technology that partially samples past frames to blend in with the current frame, so disabling the future exposes what the game looks without the temporal anti-aliasing taking place. Now, of course, you could make the argument that this is an unfair example given how the game didn't take into account people forcing TAA to be disabled with third-party mods, but this isn't the only game where this is a problem. Red Dead Redemption 2 is another example of a game where disabling TAA breaks the rendering of the game, even though the game technically lets you turn it off. And the reason for why this is a problem is that it essentially forces you to use TAA, but not because the technology is better than the alternatives, but instead because you're punished for using them even when they're better solutions. Now, I don't really have a stake in the whole anti-aliasing wars. If the only option I have is to pick TAA, I'm not gonna lose sleep over it. But make no mistakes, TAA has issues, well documented issues. Things such as blur, ghosting, temporal artifacting. It would be one thing if we had the choice to at least assess which solution is better, but this continuously becoming a first option leaves you in a situation where you're not only limited in choices, but you're also burdened with an arguably inferior solution in many cases, so much so that it's now easy to push the narrative that DLSS is better than native when the only option of comparison we have is TAA. The worst part is that I can't even disagree. DLAA and Fidelity FX AA in some instances actually do look better than the game's generic TAA implementation. But when you're comparing the image quality with an AI accelerated temporal upscaling tech with an inherently flawed AA solution, suddenly becomes very easy to hype up the vendor lock upscalers. This, my friends, is what we label the concept of creating a problem so that we can sell you a fix for it. And while we're on the subject of upscalers, let's talk about how it also started off as a voluntary thing that you can choose to enable or disable it if you so chose to. But that was nearly 10 years ago. Where are we at right now? Well, we now have more and more games that expect you to use an upscaler regardless of which GPU or resolution you're targeting. So this would also apply to GPUs like the 5060 cards that are still marketed as 1080p cards, yet if you want to run some of the latest games you're expected to use an upscaler Bear in mind that the first console that advertised itself as being able to game at 1080p was the PlayStation 3, a 20-year-old gaming device. Somehow, in 2026, it's not just that we're selling GPUs that are marketed as 1080p cards, but realistically, taking into account how we're expected to use upscalers, the actual target resolution isn't even that. At most, it's like 720p. In 2026, we're still expecting gamers to be playing the latest and greatest games at 720p. But not only that, because more and more games are forcing you to use TAA, it also means that depending on how poor the TAA implementation is, you may also be forced to use either NVIDIA, AMD, or Intel's temporal solution, something that you wouldn't have to worry about if you had other options such as MSAA, SMAA, or even MLAA, or if those options even work correctly depending on how deeply ingrained into the game's rendering TAA is. Because of that, upscalers changed for what used to be an optional feature that boosts performance at the cost of some of the image quality, is now a mandatory thing that is deeply ingrained into the expectations of both gamers and developers. And why is this a problem? Because upscalers are not and have never been perfect. Each individual upscaler has their own well-documented list of issues, especially as you lower the resolution targets. If upscalers were perfect, then there wouldn't be a reason to have newer versions of their upscalers every year. There wouldn't be a reason for the models continuously requiring more compute power to run, including dedicated AI acceleration. There's a reason for why when NVIDIA, and even to a lesser extent AMD, when they released their 4th generation of upscalers that started using the transformer model, there was so much excitement for it. Why? Because they created a problem by conditioning developers into expecting their player base to not render games natively, and now they're selling you a solution with vendor-locked AI-accelerated upscalers trying to replicate the experience of gaming at native resolutions. Except it will never reach that point, and even if upscalers continue to improve to the point where the difference is negligible, that doesn't mean that your experience as a gamer will improve. Because all that means is that developers will just start targeting lower presets. So for example, if it was acceptable to run games at the quality preset, with the next generation of DLSS, they're gonna expect you to use the balance preset, and over time, it's gonna steadily lower the standard. Meanwhile, the quality of the image is going to get worse. Now admittedly, I don't expect every developer to do this, but last year, there was a controversy with Wu Chang Fallen Feathers, a game that was notoriously unoptimized at launch. Over time, they released patches to improve the game's performance, but in one of the patches, they reduced the internal resolution of the game even when your settings were set to native, meaning not only did they lie to you about the game's actual resolution, but they also just straight up forced you to upscale the image with no real option to disable it. Now, I'm not saying every game is gonna do this, but it goes to show you just how deeply ingrained into the expectation of video game developers, which comes at the cost of the game not having the proper optimization that it deserves to have. And it's all because once upon a time, upscalers used to be an optional feature to improve performance relative to running the game natively, has now developed into a standardized feature the same way TAA once started off as an optional feature to improve performance relative to multi-sampling anti-aliasing, and has now become a standardized feature. And then we have ray tracing. Guess what? The exact same story. It once started off as an optional feature. In fact, when it originally came out, it wasn't just that it was optional, it was flat out unusable. It was way too computationally expensive to even consider running it unless you had the highest end NVIDIA graphics cards, which even then they were pushing it. But look at where we are in the present day. Nowadays, the narrative is that ray tracing adoption and hardware support have advanced quote unquote enough to the point where more and more games are becoming alarmingly more comfortable with having mandatory ray tracing, meaning that you can't even disable it. So if you have a pre-RTX or pre-RDNA 2 card, then if you're lucky, they might work through software ray tracing, which will run horribly regardless, and at worst, you're not even going to be able to run the game at all. And bear in mind, all of this strict requirement is so that the game can have advanced lighting, shadow work, and reflection. Need for Speed 2015 is able to reach arguably better visuals than a lot of these ray trace games without needing to touch a single RT core. And to be honest, this is what I find to be the most horrifying thing about ray tracing, is that it once started off as something that will only produce marginally improved result relative to pure raster, and is now getting to the point where it's selling itself through simply erasing the history of traditional raster. You see, very recently, Resident Evil 9 came out, and I have nothing negative to say about this game, don't get me wrong, except for one area where I do think that more people should be talking about, and that is with how botched the non-RT option became for rendering characters in specific areas. If you compare the end results between the options with and without ray tracing, there is a significantly more noticeable difference in the quality of the graphics. However, at the same time, if you compare the non-RT option with literally any game that has been released within the past 10 years with traditional rasterization, it's very clear that RE9 is not up to standard, at least when it comes to the shading of character models. The game overall actually still looks pretty gorgeous without ray tracing, but I always imagine how someone who's very easily dismissive of the history of lighting, reflections, and shadow work that has existed way before ray tracing started to get streamlined into video games, they will look at both these options and think that ray tracing is achieving something that is only achievable through this setting, when it's not the case. Now, of course, you could maybe argue that this isn't a big deal, Capcom is just taking advantage of the new cutting edge features, ray tracing is the future, get with the times, old man. No, I will not get with the times. Ray tracing is very expensive to run. It creates noise, the image can look grainy and blurry, so much so that both NVIDIA and AMD took advantage of this by selling their own vendor-locked denoisers. Once again, highlighting the ongoing trend of creating a problem in order to sell you a solution. And things get even worse once we start talking about path tracing, which is a technology that isn't even accessible to most hardware even from the latest generations, unless you have 90 class GPUs. And at the end of the day, the end result doesn't even look that much better than what traditional rasterization is able to achieve, nor does it even represent the most realistic graphics that you can have out there. Don't get me wrong, I'm not a realism snob. If my JRPG looks like a Gust game, I genuinely don't care. There are other aspects of visuals in video games that I care way more than whether or not it looks realistic. But if I truly did care about realism, I wouldn't be looking at current path trace games. I would be looking at games like Bodycam and Unrecord, games that don't even use hardware accelerated ray tracing. Now, they do use Lumen, which technically does have some RT built into it, but it's not the traditional ray tracing tech that we all know and love. Regardless, that to me looks way more impressive from a realism perspective, and while I'm sure a lot of it is probably a result of a lot of post-processing, but at the end of the day, that's what visual art is all about. It's not always about how many assets are getting rendered or how many calculations are happening in real time. It's also about taking shortcuts, cutting corners, tricking your visual senses. Ray tracing, I feel like it's just the antithesis of that. And you know, it would be one thing if the end results looked generationally impressive, but it really doesn't. Like, I'm sorry, I like Resident Evil 9, and I think there's a lot of aspects of the visuals that are very much worth appreciating. But if you think RE9 is some kind of technical marvel that transcends generation of video game graphics when you enable path tracing, you're just outright ignoring the history of video game graphics. RE9 looks like a normal AAA game, and that's fine. AAA games look good. In fact, I'd rather have that than whatever monstrosity DLSS 5 is. But what annoys me is just how much they gimped the lighting with the non-RT settings. And to be fair, it doesn't negatively affect every scene. In fact, in some instances, path tracing can actually turn out to be the worst pick out of all the three options, just because it can sometimes just make the characters look younger. It almost feels like they're losing details in the facial textures, which is ironic given how this is the setting that requires the most compute power. But anyway, notice how there's always a pattern. It starts off as optional, but then as the technology supposedly gets better, it slowly becomes deeply ingrained into the development process that you are essentially left without any choice. Yes, you can disable ray tracing, sometimes. You can disable TAA, again, sometimes. And usually you have the option to disable an upscaler. Except for the Wuchang example in that one instance, maybe they patched it since then, I'm not entirely sure. But at the end of the day, even if you can physically disable those options, you're still punished for doing so, because now you are expected to use these features, and the problem is that sometimes these features suck. This is why I'm not excited at the prospect of DLSS 5 neural rendering getting better, because as of right now, it's in the exact same state TAA, upscalers, and ray tracing were when they were first introduced. It's going to start off as optional, it's going to start off as something that both developers and players have the freedom to customize to their heart's content, but the second NVIDIA announces neural rendering 2.0, 3.0, 4.0, then Digital Foundry releases an NVIDIA sponsored video highlighting the improvements that these newer versions offer and how they fixed issues from earlier versions. The second consoles start using these technologies, it's going to slowly become a standardized thing where you as the player are left without any choice. You will either have no option to disable it, and even if you do, it's going to break some aspect of the game, similarly to how when you disable TAA, you're going to see some dithering. Similarly to how in RA9 when you disable ray tracing, not only does the character shading get a little bit worse, but in some scenes, there's literally no shadows. All issues that didn't exist when these technologies hadn't yet been ingrained into the development process, but then suddenly they conveniently become the solution to these problems. Once again, create a problem so that they can sell you a solution. But despite all of this, I think there is something exceptionally horrifying about neural rendering compared to the previous examples. I don't like TAA, but if it's truly the only option available, I'm not gonna completely lose sleep over it. I both dislike and resent upscalers, but in their defense, there are some use cases that I do find to be somewhat compelling. For example, if my target resolution is 4K, I think using an upscaler makes a little more sense. By that point, there's enough pixel data for the algorithm to reasonably replicate, and there's an argument you could make that you're also saving a lot of power by not rendering at 4K natively, which in my experience can easily jack up the power draw of my GPU to over 300 watts. Now, ray tracing and path tracing, I'm gonna be honest, I kinda hate that tech for more reasons than one, but even then, I could maybe see a future where hardware accelerated ray tracing has evolved to a point where maybe the performance concerns we currently have are gonna be less worrisome. I still find it to be an incredibly inefficient, gate-kept, prohibitively expensive, noisy, grainy solution for global illumination that doesn't even always look better, but neural rendering is on a whole different level of horrible. The demo that we saw required two 5090s just to produce a Stable Diffusion looking mess. I can't even imagine how much compute power this will require. It looks horrible and artificial, it goes against every principle I have towards artistic integrity. This is not creative, this is just generative AI. Even if it gets to a point where it is quote unquote usable, I don't want to live in a world where graphics are partially rendered using AI. It is dystopian, it is creatively bankrupt, and I'm already predicting a future where video game studios will start streamlining the development process by taking into account NVIDIA's and most likely AMD's neural rendering for handling the shading in real time. For quite some time, people have been complaining that Unreal Engine games all look the same, but I guarantee you it's gonna get 1,000 times worse once the neural rendering becomes standardized. And for the people that don't seem to be understanding why relying on AI to handle the rendering of your game is a horrible thing, let's look at one of the examples that NVIDIA used. If you look at the initial image, you'll notice that it has this warm, diffuse lighting that conveys this sunny temperature that is very distinct. But if you look at the image with DLSS 5 on, it just removes that warm sunny tint. The light bouncing to the character just looks like a generic Instagram filter. The items on the right side had this blue haze that wasn't even in the original image. So all DLSS 5 really did was add artificial visual information that replaces the original, much more distinct look that the first image had. If you don't see why this is an issue, I just don't think we have the same values. Here's my point of view. I think more people should learn how to reject new technology. We need to stop falling for the marketing gimmick of X technology is the future, the same way people were saying that ray tracing is the future or nanite is the future. Because guess what? We were hearing these exact words more than 5 years ago. And the present sucks. The truth is, much like with DLSS, TAA, and ray tracing, the worst days that came upon us weren't when these technologies initially came out. It's when they got quote unquote better, because them getting better is what signaled the industry to start using them unapologetically, and that's when things truly went into the abyss. All because we didn't reject these technologies hard enough. But with DLSS 5, we need to learn from our past actions. Deny it, reject it, show opposition. Once we start doing that more, maybe they'll think twice about doubling down.